Imagine a desert so brutally dry that NASA uses it to test their Mars rovers, because its barren terrain is the closest thing on Earth to the surface of the red planet, a place where rain hasn't fallen in recorded history. Yet thousands of people living in tiny isolated villages extract over 400 liters of fresh water every single day, straight out of thin air. No underground pumps, no electrical grid, and not a single river in sight. So how are they harvesting liquid life from rainless fog? In the most arid environment on Earth? Welcome to the Atacama Desert in South America, a narrow 1,000-kilometer strip of land wedged between the Pacific Ocean and the towering Andes Mountains. In this sun-scorched wasteland, moisture is virtually non-existent, and survival seems statistically impossible. Yet, against all odds, thousands of people thrive here by combining ancient survival wisdom with brilliant zero-electricity engineering. To understand this magic, you have to look at the geographical paradox where this brutal desert meets the ocean. Running right alongside the coast is the Humboldt Current, a freezing cold ocean stream originating from Antarctica. As warm desert winds blow west toward the coast, they collide directly with this icy oceanic air. This extreme temperature contrast triggers a unique meteorological phenomenon known as a thermal inversion. Instead of rising into the sky to form rain clouds, the moisture gets trapped under a heavy blanket of warm air above. The result? A thick, dense, atmospheric wall of ocean fog, known locally as the Camanchaca. Every single morning, as the sun begins to heat the desert, this heavy ocean fog rolls over the coastal mountain ridges, carrying billions of microscopic water droplets. But here is the tragedy of the Atacama. Because the desert ground air is so scorching hot, these droplets are too tiny and light to condense into actual raindrops. They simply float in the air between 500 and 1,200 meters above sea level, drifting harmlessly over the thirsty land below without dropping a single splash of water. Centuries ago, long before the invention of modern meteorology or material science, indigenous coastal tribes like the Chango people figured out a secret. Living in one of the most hostile environments on the planet, they observed their surroundings with extreme precision. They noticed that while clouds never produced rain, the leaves of native desert trees like the garofero and the sharp edges of coastal rocks were always dripping wet during fog season. The Chango people realized that nature was already collecting the water. It just needed a surface to cling to. They began placing crude clay pots and animal skins beneath these plants, harvesting just enough condensed moisture to survive the brutal summer months. For generations, this ancient biomimicry kept small coastal communities alive. Fast forward to the modern era, and visionary engineers took this ancient survival trick to a revolutionary scale. Instead of relying on sparse desert trees, they began building massive, vertical billboards on top of mountain ridges holding a special synthetic mesh known as Raschel nets. Think of these nets like a giant magnet for clouds. The system doesn't filter water like a traditional purification plant. Instead, it forces tiny microscopic water droplets drifting in the wind to physically collide with the net threads. Through surface tension, these tiny droplets hug each other upon contact, merging into larger, heavier water drops. Once the drops reach a critical mass, gravity takes over. The water trickles down the face of the net, falling directly into a simple PVC gutter attached at the bottom. From there, it flows through gravity-fed pipes directly into large storage tanks situated down in the villages. The structural design of these fog catchers is a masterpiece of passive engineering. Constructed using heavy-duty wooden or steel posts, the nets are angled precisely perpendicular to the prevailing ocean winds. The Raschel mesh itself, made of durable high-density polyethylene, is engineered with a 35% to 50% shade rating. This exact density ensures that wind can pass through the net smoothly without blowing the structure over, while still capturing up to 60% of the airborne water droplets. The efficiency of this setup is staggering. A single square meter of mesh can extract anywhere from 3 to 10 liters of pure drinking water in just 24 hours. A standard array of large collectors, measuring 40 square meters each, can produce hundreds of liters of fresh water daily. All of this occurs with zero electricity, zero fossil fuels, zero solar panels, and zero moving parts. It is 100% powered by nature, gravity, and the wind. In fact, the harvested cloud water is so clean, pure, and mineral-rich that local entrepreneurs in Chile have actually built a commercial brewery called Atrapaniebla, crafting world-famous craft beer made entirely from harvested fog. But while locals are turning clouds into beer, material scientists are asking an even bigger question. How can we make these nets twice as efficient using nature's own blueprints? By studying the Namib desert beetle, which catches fog on its bumpy shell, and the microscopic structure of spider silk, researchers are now designing super hydrophobic next-generation fog nets. These advanced materials can extract water, even in environments with extremely low humidity levels, promising a potential solution for water-scarce regions across Africa, Asia, and the Middle East. The Atacama fog catchers prove a powerful truth. Even in the harshest environments on planet Earth, you don't always need complex high-energy technology to solve massive human problems. Sometimes, the most brilliant engineering solutions are the ones that work in perfect harmony with nature itself. If you could build one zero-electricity technology in your own hometown, what would it be? Let me know in the comments below. If you found this ancient engineering breakdown fascinating, hit that like button and subscribe to NEXA for more incredible stories of human survival, lost technology, and ancient mysteries. Until next time, thanks for watching.